Now the first ones we're looking at are these here, direct inverse variation or neither. Now direct variation came in the form of y is equal to a times x, or we could say x is equal to a times y. Either one works. The other variation we had for direct variation is x over y is equal to a. We could say y over x or x over y. Either one is the same thing. Now inverse variation was y is equal to a over x. Or we could say x is equal to a over y. One's on top, one's on bottom. And the other version of inverse is y times x. X times y is equal to a. Now these are the four main versions of direct and inverse variation that we can have. It's going to be in one of these here. So if we look at these here, number one would be what? Direct. Number two is inverse. Even though the x and y are flipped, it's still inverse. And the main giveaway is the plus. And again, with any of these here, we need x and y. Because if you remember that from the last test where it just y equals 4, it doesn't work because we need two variables. Number 4 would be inverse. Number 5 would be direct. And 6 is and that's it for these here. Because we're just identifying it as direct, inverse, or neither. And the biggest giveaway for neither is that it's going to have plus. Questions on 1 through 6? So again, I would make sure that you do have the direct and inverse variation equations down. I do have them here. Now, addition, subtraction, next to my computer. There should be one that's sharpened. We need the denominators to be the same. If they are the same, then we can add or subtract the numerators. So on the first one, number 7, both denominators are already the same. They're both 8v. So for this one here, we're adding. We can go on and add the numerators. So I have u minus v plus 6u minus 3v. U plus 6u is 7u. Negative v minus 3v is negative, not 3, negative 4v over 8v. Now we do need to make sure nothing factors. Well, 7u or 4v, do we have any way to factor those? No greatest common factor. Since there's no powers, there's nothing we can do with sets of parentheses. So that's as far as it goes. So that's the answer. Now, with a lot of the addition subtraction problems, there's a good chance that nothing's going to simplify. It's unfortunately just how it works. It takes more tinkering and manipulating with the equations to actually get it to have something in common on top and bottom. So most of them are just going to end up, this is what it is. Now, we'll go on and do number 8 as well. Are the denominators the same? Yeah. But will a squared plus 3a plus 2 factor? Yeah. So there's one of two things we can do. We can either A, factor it now, or B, factor it after we add and subtract. Might as well go on and factor it now. 2 sets of parentheses. Now, since the 2 is positive, our signs are the same and match the sign in the middle term. So plus and plus. Factors of a squared are a and a. And factors of 2 are well, since we know the second one is the same thing, we can copy it over. Since the denominators are the same, we can add the numerators. Now, since we are using addition, we don't need the parentheses because there's not going to be a sign change. Now, at this point here, if you'd already gone from, say, here to down here, saying 4a plus a is 5a, 4 plus 1 is 5, that's fine. If you had it as 5 plus 5a, same thing, 5 plus 5a, and 5a plus 5 are the exact same thing. So if you'd gone on, instead of writing it 4 plus a plus 4a plus 1, you just written as 5a plus 5, that works just fine. Now at this point here, we could say that this is the final answer as long as nothing factors on top. Can we factor 5a plus 5? Yes. They have a greatest common factor of 5. And if we factor it out, we get 5 times a plus 1 over plus 1 times a plus 2. Now we do have something in common on top and bottom. We have the a plus 1 and a plus 1, which do simplify, leaving us with 5 over a plus 2. Now, kind of reiterating, changing the statement I made earlier. If the denominators you're adding or subtracting and they're already the same, there's a good chance something might simplify. But like problem number 9, which we'll look at next, if we're actually trying to make the denominators be the same, the likelihood that something's going to simplify out at the end is low. It's just harder to make them work out so that they do have something in common on top and bottom when you're doing those. Questions on 9 or 10? 10. With the denominators, we need to factor them if they are not already factored. So with 2x minus 2, 2x and 2 have a greatest common factor of 2. Because whenever we're factoring, greatest common factor should be the first place you check. And I can factor a 2 out of both terms, which will leave me with x minus 1. So when we factor the 2 out, we get 2 times x minus 1. X squared minus 4x plus 3. There's no greatest common factor, nothing we can pull out of all three terms. It will be negative and negative. Since the 3 is positive, our signs are the same and match the sign of the middle term. X squared's factors are indeed x and x. 3 and 1. Questions on how we factor that there? Now, for us to be able to add or subtract, we need to multiply top and bottom of both fractions by something to get them to be the same. Now, what does the one on the left have that the one on the right doesn't? It doesn't have the 2. One on the left has a 2, the one on the right doesn't. But yes, the one on the left doesn't have the x minus 3. So we'll have to multiply the one on the left on top and bottom by x minus 3. We have to multiply the one on the right by 2 on top and bottom. Now looking at this here, the denominators, will we have to combine any like terms on the bottom of these fractions? Well, no, it's just going to be 2 times x minus 1 times x minus 3. We do not have to multiply through the denominators when we add or subtract. We don't have to multiply through these parentheses. However, the numerators, we're going to actually have to subtract. So the one on the left, we need to actually distribute this out. X times x is going to be x squared. X times 2 is going to be plus 2x. Negative 3 times x is going to be negative 3x. And negative 3 times 2 is negative 6. We have to multiply those through. The same with the other side. We have to multiply the negative 2x and negative 1 by 2, which gives us negative 4x minus 2. Now, before we subtract, I would combine like terms. And the only place we really have like terms is the first set of first numerator. And negative 3x and 2x is going to combine to give us negative x. Now, at this point here, we do need to subtract, because the first one, x squared minus x minus 6, the signs are not going to change because we're not subtracting it. The ones that are the second set. So there's one way we could do it is rewrite it with parentheses around the negative 4x minus 2 and then distribute the negative. If we feel comfortable with doing this subtraction and applying that negative to both, we can, which will really just tell us that we have x squared minus x minus 6. The negative and negative 4x will make it be plus 4x. The negative and negative 2 is going to make it plus 2. Now we combine like terms in the numerator, so we'll have x squared. Negative x plus 4x is going to be plus 3x. And negative 6 plus 2 is negative 4. Now, most likely on the test, this is where you're going to end up stopping, because the numerators will not factor. They're as simplified as they get. Even if they do factor, they're not going to give us something that will cancel out. However, with this here, yeah, we'll have two sets of parentheses because we only got one step after this. So we have plus and minus. So x and x, 4 and 1. Which one would be positive? And the 1 is negative. And we have this for two reasons. One, because the middle term needs to be positive, so we'll want the bigger term positive. And also, with the 1 being negative, we do have something in common on top and bottom, giving us x plus 4 over 2 times x minus 3. That's it. Any questions over any of this here? Questions on 11 or 12 or 13? I'm trying to remember 13. Yep. Wow, okay. Look at this one last time. oddly enough, I did not put a single complex fraction on the test. So 11 through 13 aren't going to show up. They're not. Need a sharpener? Okay. 11, 12, 13 are not going to show up on the test. Questions on 14?
Give us all A's.
So, multiplication. Whenever we multiply two rational expressions, the first thing we need to do is factor each of the numerators, each of the denominators. We need to factor them. Now, looking at 14, x plus 7 and x minus 8 are as simplified as they get. Nothing we can do to them. There is no greatest common factor. They are simplified. But 7x plus 35, that's on division.
Oh, yeah.
So 7x plus 35, again, first thing we need to look for, greatest common factor. Is there a greatest common factor between 7x and 35?
Yeah, 5.
We get a 5, yes. So we can pull 7 out, which would give us x plus 5. Because 7 does go into 7x and 35. 7 out of 7x gives us just x. 7 out of 35 gives us 5. So we have this here. Now at this point here, we don't have anything that simplifies on top and bottom. So we're hoping x squared minus 3x minus 40 will give us something that does. No greatest common factor, nothing we can pull out of all three terms. But since the 40 is negative, our signs are positive and negative. They're opposite. Factors of x squared are x and x. Now factors of 40, yep, 1 and 40, 220, 410, 5 and 8. Indeed, 5 would be positive, 8 is negative. And we could go through and do the factors, but we also know that if something's going to simplify, we're going to need probably an x plus 5 or an x minus 8. Now at this point here, we can multiply these together, and the x minus 8 and x minus 8 will cancel out. The x plus 5 and x plus 5 will cancel, leaving us with x plus 7 over 7. Pretty close to it. There's not going to be one on the test that doesn't simplify at least once. So it's not going to be that we factor it out and that's just it. There's nothing that cancels. There will be at least one set of parentheses or one thing on top and bottom that will cancel in every single multiplication and division. Now, if a multiplication or division problem already has them in kind of factored form, we have our sets of parentheses multiplied together, we just have to do the multiplication or division. We don't have to multiply it back out. We just need to cancel. Kind of like the one on the first test where we just flipped it and then everything simplified. We can just, if it was division, flip it, simplify. If it's multiplication, just start simplifying. Questions on any of this here? 15. So multiplication, we can go and just start factoring first. X squared minus 25. Two terms, one squared. Is x squared a perfect square? Yes, it's x and x. Is 25 a perfect square? 5 and 5. So we'd have x plus 5 times x minus 5. X squared minus 9. There's no greatest common factor, two terms, and it's minus, so our signs are opposite. They're both perfect squares because x squared is x and x. 9 is what? 3 and 3. Now we can factor x squared plus 6x plus 9 first, or we could have done x squared minus 3x plus minus 10. Either one. X squared plus 6x plus 9. No greatest common factor. But since the third term is positive, the signs are the same and match the sign of the middle term. X plus and plus. Factors of x squared are x and x. We do have 1 and 9, but we also have 3 and 3. 3 and 3 is helpful because now we have an x plus 3 on top and bottom, yes? So they will cancel out. The denominator, x squared minus 3x minus 10. So since the third term is negative, the signs would indeed be opposite, positive and negative. Factors of x squared are 5 and 2. Since the middle term is negative, we want the 5 to be negative. And we did say we had an x plus 3 in common on top and bottom. We also have n x minus 5. So what that leaves us with is x plus 5 times x plus 3 over x minus 3 times x plus 2. So here, even though we do have more than one set of parentheses on top and bottom, something did simplify. But that's it. Yep. The x squared, the first rational expression on this one here would be the only one that factored, because the x plus 8 over x minus 3 is simplified. So we just simplify from there. Any questions over any of this here? We ready for division? Do we want to look at 17 or 18? Let's look at 17, since 17 actually has more factoring to it. Now, the first thing we want to do is change it from division to multiplication. Keep the first one the same. And flip the second. Now, the first one that we factored, it really doesn't matter where we start. We just need to pick one to start. We can. Now, if you notice all four of these, there is no greatest common factor. There's nothing we can pull out of any of these here, so we don't have a greatest common factor in this one specifically either. Since the 21's positive, the signs are the same and match the sign of the middle term, negative and negative. Factors of x squared are x and x. Now, factors of 21, 1 and 21, and yes, 7 and 3. We'll want 7 and 3 because they do combine to give us negative 10. X as the middle term. Where do we want to go next? The bottom. This one here is nice. Negative 5 means the signs are opposite. Factors of x squared are x and x. Factors of 5 are 5 and 1, 1 and 5. Which one do we want positive? Which one negative? 1 positive, 5 negative, because the middle term is negative, so the bigger term is going to be negative. The only reason that wouldn't work is if we actually have something other than just x and x, so 2x, 3x, then we'll need to check it a little bit more. But as long as we have just x and x, if the middle term's negative and we have opposite signs, bigger number should be negative, or vice versa. So we can look at x squared minus x minus 20. No greatest common factor, but since the 20 is negative, our signs are opposite. Factors of x squared are x and x. Well, 5 and 4. Which one's positive? Which one's negative? 4 is positive, 5 is negative, because again, the middle term is negative, so we want a bigger negative term. But also, if we do have a negative 5, we now have something in common on top and bottom. Last one, x squared plus x minus 12. Since the 12 is negative, our signs are opposite. X and x. Factors of 12 that we want are 3 and 4, 4 and 3. Since the middle term is positive, opposite signs, the bigger number should be. So the 4 should be positive, the 3 is negative. But also, if we do have x plus 4, we do have something in common on top and bottom. Questions on how we factor these 4 here. X plus 4 and x plus 4 will cancel. X minus 3 and x minus 3 will cancel. X minus 5 and x minus 5 cancels, leaving us with x minus 7 over x plus 1. And that's it. Any other questions with division? Division is essentially the same as multiplication except for our first step where we keep, change, flip, and everything else is the same. Do we need to see another example with division? Number 19, yes. I will tell you number 18. This answer should be x plus 3 over x minus, or x plus 2 times x plus 2. I wrote the wrong answer on the back. So for the answer key, this is what it should be. Okay? We'll go on and look at number 19. Now, the first thing with 19 is we're going to keep, change, flip. Keep the first one the same. Flip the second. And it's going to be multiplication now instead of division. Now looking at these 4 here, is there a greatest common factor in any of them? 3 of them have a greatest common factor. X squared minus 64 is the only one that actually doesn't have a greatest common factor. But it is a difference of perfect squares. Because what times itself is x squared? X and x. What times itself is 64? So we'd have x and 8, and then we'd have plus and minus. Now we look at the denominator, 2x squared minus 18. Is there a greatest common factor? 2. So the first thing we'll need to do is factor the 2 out, which will leave us with x squared minus 9. Well, hey, x squared minus 9 is a difference of perfect squares, yes? We'll factor it in a minute. Let's look at the others. 4x squared minus 16x plus 84. Is there a greatest common factor? Because 4 goes into 4. 4 times what is 16? 4. And 84 is also divisible by 4. So if we divide it out of all 3 terms, we get 4 times x squared minus 4x minus 21. And lastly, it's 2x squared plus 32x plus 128 is actually all divisible by 2. Okay. I'd say the next easiest one to factor is our x squared minus 9, yes? X squared minus 9 is a difference of perfect squares. X squared is x and x. The factors of 9 are 3 and 3. So we have x plus 3 and x minus 3. What are we hoping is in the other denominator? One of those fractions or sets of parentheses to be x minus 8 or x plus 8. Because our 2 numerators that we have so far are x minus 8 and x plus 8. So if we have one of those, that would be nice. So if we look at x squared plus 16x plus 64, since it's positive 64, signs are the same, match sign in the middle term, plus and plus. Factors of x squared are x and x. Factors of 64 are 1 and 64. 2 and 32. 3 doesn't work. 4 and 16. 5 doesn't work. 6 doesn't work. 7 doesn't work, but we do have 8 and 8. Which one do we want? 8 and 8. Numerator. Since the 21 is negative, our signs are opposite, positive and negative. Factors of x squared are x and x, right? 21, well, 1 and 21 are 3 and 7. Middle term is negative, so the bigger number should be negative. Smaller number should be positive. Because x and x, we don't have a number in front of them, so we can do this here. And then we will multiply together, yes? Easiest ones to see, x plus 3 and x plus 3. We also have x plus 8 and x plus 8. Anything left that's in common on top and bottom? Right. Because we do have 2 over 4, but we also have 2 2's on top and bottom, yes? Well, 2 times 2 is 4, so eventually these will cancel out. And on top we have x minus 8 times x minus 7. On the bottom we have x plus 8 and x minus 3. So really all we have left is x minus 8 times x minus 7 over x plus 8 times x minus 3. Because the 4 over 4 will simplify to 1. And more or less it is gone. Any other questions on this here? We feel good with addition, subtraction, multiplication, division. Let's look at solving. Do we want to look at 20 or 21? 20. Now again, with solving, normally the first thing we would look for, when especially we went back over it, was restrictions. Now, I'm going to be nice to y'all on the test. If it has restrictions, it's going to say, either in the instructions for problems, whatever, solve the following equations, check for restrictions, or it's going to say out to the side, check for restrictions. Because if that's not listed, there's not going to be restrictions coming into play. So for 20, there are no restrictions that are going to come into play. So we can go on to the next step. And our first main step with solving after restrictions is getting all the fractions to simplify. So one of the things I know I can multiply everything by to get the fractions to reduce is x minus 3. Because on the right, the x minus 3 and x minus 3 will cancel. Are all the fractions simplified? We also need an x minus 4. Because over here, the x minus 4 and x minus 4 will cancel out. Now all the denominators are simplified. And what that does leave us with is x minus 3 times x minus 3 is equal to 4 times x minus 4. And yes, x minus 3 times x minus 3 is the same as x minus 3 squared. But since we're actually having to multiply through, it's going to be better to leave it as x minus 3 times x minus 3. So that when we distribute, x times x will indeed give us x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is going to be plus 9. On the other side, we'll distribute the 4, and we'll get 4 times x is 4x, and 4 times 4 is negative 16. Any questions on this so far? Now, if we do have, yes, let's combine like terms first. Is negative 6x. Because if we can combine like terms, we'll need to. It's going to make it easier to solve. Now, once we combine like terms, we have an x squared term, yes? We need it equal to 0. If we just have an x, we don't have any x squared terms, get x by itself and solve. So the first thing we can do is Subtract 4x from both sides, telling us that x squared minus 10x plus 9 is equal to negative 16. And then we would add 16 to both sides, telling us that x squared minus 10x plus 25 is equal to 0. Questions on how we got to this point here? Factor. Yes. Because once we get to this point here, we can factor it. Since the 25 is positive, the signs are the same and match the sign of the middle term, negative and negative. Factors of x squared are x and x. And the factors of 25 that we want are indeed 5 and 5. Whenever we have two or more things multiplied together that equal 0, one of them must be 0. Now for the first one here, we can add 5 to both sides, telling us x is equal to 5. Here we can add 5 to both sides, telling us x is equal to 5. And if we'd have graphed it, we'd see that it hit the x-axis at 5 but didn't cross it. And whenever it touches the x-axis and never crosses it, we have a multiplicity of 2 with quadratics. Questions on this here? Questions on any of this so far? Mm-hmm. Yes, we will. And the only main difference with the one with restrictions and the one that doesn't is that we just remove those solutions. So it'll be the exact same process, except we would see, hey, x cannot be, say, 5 for this here, so we'd mark it out. Any other questions on these here? Now, we'll come back to this here in a second. 29 through 32.
Did the junior officer meeting today in Homer's room during chant? Also, there's a senior meeting today in Mr. Clement's room during chant. Thank you.
29 through 32, all you're doing with these here is factoring the top and bottom. And then simplifying, canceling out what's in common. So essentially the last step in multiplication, once we factored, doing that there. So there are questions on these here. Because here, the numerator is going to be x minus 5 times x plus 2. The denominator is going to be x plus 2 times x minus 1. So the x plus 2 and x plus 2 would cancel, leaving us with x minus 5 over x minus 1. And that would be it. So we just factor top and bottom, cancel out what's in common, and that's it. Because 30 is doing, the rest of them are doing the exact same. Start with factoring top and bottom, any sets of parentheses in common, cancel out, and we have what's left. So we good with 29 through 32. Well, I'll look at 27 here. Now, I can guarantee the bell is going to ring before we finish. So if you want to stay and watch the rest of it, that's fine. If not, that's also fine. Because with any of these here, with solving, we want to factor the denominators.
During camp, I need all high school cheerleaders to report to the old camp. Thank you.
Factor. So x squared minus 1 is the only one that does factor. It is a difference of perfect squares, so we will have x plus 1 and x minus 1. Now our restrictions for this here are going to be 1 and negative 1, because x minus 1, 1 minus 1 would be 0. X plus 1, negative 1 plus 1 would be 0. Then we're going to multiply everything by x plus 1 and x minus 1. So it's the exact same as what we did on the last solving one. It's just at the end, one of the solutions is not going to work. So we multiply through, x minus 1 and x minus 1 will cancel. In the middle, x plus 1 and x plus 1 will cancel. In the last one, both of them. So on the one side, we just have 4. The first one here, we have x plus 7 times x plus 1. In the middle, we have x minus 1 times x minus 1 is equal to 4. Now at this point here, we do need to distribute. X times x would be x squared. X times 1 is x. 7 times x is plus 7x. And 7 times 1 is going to be plus 7. We'll do the same thing with our next set. X times x would be x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is plus 1. So again, I will post this later if you want to go back and look at it. Now at this point here, we can combine like terms. So for the first time in one of these here, we do have x squared plus x squared is 2x squared. X, 7x is 8x minus x minus x. So we're combining x's. So x plus 7x is 8x. Minus x is back to 7x. Minus x is 6x. 7 plus 1 is plus 8 is equal to 4. Now, we do need to get this equal to 0. So we minus 4 from both sides, telling us that 2x squared plus 6x plus 4 is equal to 0. We can factor, but this one here, if we do notice that all three terms do have a common factor of 2, so if that is the case, you can divide the whole thing by 2. So guys, come in quietly. Finishing this up here, which would give us x squared plus 3x plus 2 is equal to 0. Yes? Now at this point, we can factor. Guys, quietly. Thank you. Here, plus and plus, factors of x squared are x and x. And the factors of 2 are 1 and 2. Yes, we're finishing up the review. We get this here. Now, because we do have two things multiplied together to equal 0, one of them is going to be 0. We can subtract 1, telling us x is negative 1. Here we can subtract 2, telling us x is negative 2. So we get these two here. So, guys, hold on. So, these are the two solutions that we have. Now, at the beginning, we said x could not be negative 1. So the only solution is x is negative 2. And that's it. That's the only difference between normal solving and ones with the restrictions, is that at the end we throw one out. But that's it.